Here's another diagram of a diffraction grating practical, and here are our maxima, our bright fringes on the distant screen. Now remember that a bright fringe is where all the waves arrive in phase, and so you get constrictive interference, they all add up to give you a maximum. Now in this practical, we don't just have 2 waves in here, we've got thousands. So to get a maximum, we don't just need 2 waves to arrive in phase, we need all however many thousand waves to arrive in phase to get a maximum. And that's why there aren't as many places where that happens. So you get one here and you've got to go all the way along there before you get another place where all those waves are arriving in phase. And remember, it could be over a metre between those two. Okay, but how do we use the formula? Well, you'll notice that I've put values of n along here, and these are called the orders. So the central fringe there, the central maximum, that is called the 0th order fringe. And then on either side of that, you've got the 1st order fringes, and then outside again, you have the 2nd order fringes, and so on. And that number is what's going to go into this formula. So if you want to use the formula, you choose one of the fringes. So let's say I'm going to choose, I might go for this one here, the second one. So I'm going to go for this 2nd order fringe. And so I'm going to measure that distance, so the distance from the centre of the grating to my 2nd order fringe. And then I'm also going to measure this distance, which is the distance to the central fringe, and then I'm going to use those 2 distances to calculate my angle here. So that's my angle theta. It's the angle between that line and that line. So let's just say that that came out as, I don't know, 25 degrees. Then to use our formula, we've used n equals 2 there, so we would have 2 times lambda is equal to d. Now I've said that that's 3 times 10 to the minus 6 times sine 25 degrees. And so that would give me a value of lambda of 630 nanometers, pretending that I had 2 sig fig there. So here's a question where we're using the diffraction grating formula. Okay, so the first part is just like what we did in the previous video. So there's 1 millimetre has 300 lines in it. So that's our D value. Then we're also told the wavelength, and it's the 1st order spot. So that means n equals 1. And leaving you to follow through the algebra, that should give you a value of theta of 11 degrees.